So we are at the last script now, where we have done our deviation calculation by district. We have our results. This script is all about visualizing these results in a better way. So in the last step, we saw how we can use the reduce regions function and give it a feature collection where we can compute the deviation for each district. And at that point, you can just export your results as a shapefile and download it, and you'll have your results all computed using the 30-year chirps data. But now what we want to do is we want to kind of visualize these results better on the map here, where by default, as you can see, we can take our feature collection, and the visualization parameters just takes a color. So we can just say this is the color of our each district, and that's it. By default, you can't really visualize it in any better way. So each of this has a parameter. If I click on it, it's got a value of the deviation in this property called mean. And it'll be nice just to visualize this, where we can say we can have a same symbology, like, red means higher deviation, blue means more positive deviation. So how do we visualize it? So to show that, let's just, I want to show you this section of the user guide. Styling vector data in Earth Engine is not straightforward. And that's why I want to point you to the user guide, where they show how exactly you can do this. So if you go to this feature collection overview, and there is a section on feature collection visualization. And this section contains how you can visualize this. The key idea here is that Earth Engine can visualize everything as images. So you need to take your feature collection, which is the vector data, and convert it to an image, and then you can display it in any color or any style you want. And this goes on through the different processes. I'll show you in the script, but you can refer back to this user guide article to really learn more about it. So the concept is you create an empty image, where you are creating an empty image and you start painting over it. You can say, take my blank image, paint it with these colors, one for each polygon, and then you can display it like that. So I'll go display the process. First, we'll create an empty image, and this will be ee.image. You can just create an empty image and convert it to byte, which is a byte image contains values from 0 to 255. And that's enough, so we can style our images based on that value. If the values that you want to compute, want to store are larger than 255, you might want to use 2 int 16 or something like that. Okay, so let's just say we'll style this image. We'll say styled image equals, let's take this empty image and paint it. So the paint is a function which takes all of this arguments. So let's say give a feature collection. So we'll say our feature collection is this district deviations, and the color is the mean value. So read the color from the mean values here. And now let's just look at this. We'll use the same parameters here. So we are using -60 to +20, and just look at this image now. So we'll say map.add layer. And this params. So now we are looking at the styled image. So I think there is an error here. The styled image. Oh, I think I have an extra D here. That's why. So when I run this, I'll just turn off the 2 layers so I can see the currently styled layer. And there you go. Now you can see the images now appear. This is the feature collection that is styled. So remember, this was our raw image. We don't want to display images. We want to display our districts colored by the actual deviation that is stored in the property. So we took an empty image, painted it, and now we have this nice image where you can see the district boundaries and the deviation. You can see which districts have high deviation versus low. One more last step you want to do is, you can see the districts up here. You can't really see the boundaries. So it'll be nice to just have the district boundaries also appear on this. And to do this, what you need to do is you can actually take this image and paint it again with just the borders. So let's see how to do that. So we'll add an outline to it, and we'll take the styled image and paint it again. And the feature collection we want to paint is this district deviation. And instead of specifying a color, which is reading from an attribute value, you can just say give it a single value. So we'll just give the value -70 to each color, because -60 is our deviation, where the deviation starts for. So we'll just specify this, and we'll give a width now. If you give a width, that is will be rendered as an outline. And all of this is documented in that article I showed you. This is just to show you that you can take an empty image, paint it again with the borders, and we can visualize this. Here we need to change the viz params a little bit, because now our visualization actually starts from -70, where -70 is that borders. So we'll just do border, and then we'll add one more color at the beginning, which is the border one. So this is the gray color code, and now we have a palette that goes from -70 to +20. And now I can add this outline. And this params, and I can save it outline. So I'll just turn off everything else, and we'll just show the final map, which is got the districts, and they are colored by the amount of rainfall deviation for the year 2016. And this is the end of the project. You can see the visualization is a little hard in Earth Engine, and it's, you really don't want to use Earth Engine for visualization. I would recommend, if this was a project that you're working on, you should just export the data. Once you do your reduced regions, you'll get a feature collection with the average deviation value. Just export this as a shapefile, get it to QGIS or other GIS software, create a nice map, and then you can present your result. But if you want to do this in Earth Engine, this is the way to do it. And that's it. We've come to the end of the project. Thank you for watching, and thank you for coding with me. Hope you understood and got some practice of coding. I highly recommend, again, if you just watched it, didn't code, go back and try to code this yourself. Unless you code and unless you practice programming, you can't learn it. And happy coding. Thank you.